Hello everyone. So in this video, I'm going to explain you guys about feature engineering. So let's get started with the video. I hope you understand what I meant to say. So yeah, feature engineering is the art and science of formulating new predictive attributes from raw data to enhance the performance and accuracy of machine learning models. It transforms raw observations into formats that algorithms can digest more effectively. One hot encoding. Machine learning algorithms typically require numerical inputs and cannot directly interpret categorical labels, labels like red or blue. One hot encoding resolves this by converting these categories into binary vectors that are zeros and ones. For instance, a color column is split into separate colors columns like is red, is blue, is green, or something, some other colors that are required in the table, that are written in the table actually. So so all of these columns get separated and another in different color formats, in different color columns, where a value of 1 indicates the presence of that feature. So yeah, so in short, one hot encoding is something very basic to understand, that if the value is present into the column, if the column is present in the raw data, it will show it as 1. So 1, that indicates the presence of the feature. If it's 0, it's not present there. So simple. Now comes scaling and normalization. So when dataset contains features with vastly different ranges, example age, salary, and other things, algorithms may incorrectly prioritize the large numbers. Scaling standardize these values, typically adjusting them to a common range such as 0 to 1, ensuring that all features contribute equally to models' calculations. Binning, that is also known as discretization, which is the technique to reduce the noise in continuous data by grouping values into broader intervals or bins. A practical example of it is that converting specific ages, so such as 4, 12, 17, any ages, any range of ages, into a single categorical group labeled as children, which are aged from 0 to 18. So yeah, here you can see that by binning, you can actually put it into a range where binning, that is discretization. In this technique, you can actually group things into things that are labeled and that are much understandable after grouping. So as the example shown here, uh, a specific age group was present before, that are just randomly throwing numbers 4, 12, 13, 20, 18. So in this binning, this all of these ages are now grouped, and we have given it a label such as child. And in this child bin, we have just did the same with this. We have just did the single thing, which is grouping the things from 0 to 18. So that covers all the age groups, and we don't need to add jumbled words or jumbled numbers in that group. So it's pretty easy now. So which can help the model identify general patterns rather than getting lost in minor fluctuations. Yeah. So what are the imputations in this? So as previously discussed, this involves handling gaps in the dataset. In the context of feature engineering, simple strategies including filling missing entities NaN with a static value such as 0 to prevent algorithms error during processes is actually appreciated. So this is from my side on to the topic of feature engineering techniques, and thank you for watching this video. I hope you understand.